have a volume of 10 cubic feet.
Stop right there. We got a box. Make it large enough so we can see it. It might do this. Now he's telling me, Professor, this box finally get the sketch done here. As that looks like this. So I'll know what they're talking about here. Now you guys moving on to Math 7. I do know one professor who always has this problem on his first calc test. He just loves this box problem. He will ask you, in addition to what I'm going to do, some more things about it. Guys, there's the box. It's supposed to have a square base. So on the bottom there, it's supposed to be a square. And since I do not know, did they tell me what size this was down here, the square? Was it a 2 by 2, 3 by 3? They didn't tell me. So let's call it X and X, unknown, all the way around. Did they tell me the height of the box?
They do not.
They did not, so we'll call this H for height. Now read the last part of that problem. We got the box.
Express the amount of material used to make such a box as a function of the length x of the side of the square base.
Did they tell me, I think I heard the word volume was mentioned.
Yeah, 10 cubic feet.
Oh, this thing will hold 10 cubic feet, let's say, of water. I can pour that much water into it. That was given to me. But they want to know how much material was needed to build this box, I think. Did they say it was open at the top?
I don't think they specified.
They didn't say, just a box?
Oh, yeah, sorry, open box.
Open box, so that means this top, I need not worry about it, it's open at the top of the box. Guys, the volume of a box formula is length times width times height. That'll give you cubic units. With what he gave me, I know it's X times H. Here's the length, here's the width, here's the height. So that 10 he gave me can be expressed as X times H. Or 10 is equal to X squared H. There's my volume expressed. Now though, you'll say, well, why don't they ask me to find, Professor? If you don't mind, go back to the beginning and read the first part to me one more time.
An open box with a square base is required to have a volume of 10 cubic feet. Express the amount of materials used to make such a box as a function of the length x of the side of the square base.
Thank you. Now they're asking me, here's my job and your job, is please come up with how much material, in other words, the area. They want the surface area of this box. Find, we'll call it surface here, the surface area of this box. They gave you the volume, now they want you to find the area, surface area. Now the bottom's supposed to be a square. I mean, it don't look like a square the way mine's drawn. It's supposed to be a square. I know the area formula from middle school, even before, for a square or a rectangle. Length times width, so X times X will give me a start here, that's X squared. Should I include the top? Because that should be another square up here. Would that be another X squared? No, I think you told me the top is what? Open. Now on the quiz on Wednesday, if yours is closed, if I say it's a closed box, then you'll have another one of these. X squared plus another x squared. In this case, no. Now, we use different colors here. There's more to this box as we tear it apart. There's this piece over here. I need to express the area of that rectangle on the side there. Well, since it's a rectangle, base times height, length times width, that would give me what? X times h to add here. Please tell me, if I jump over to the other side of the box, tearing the box apart, there's another piece, I'll use the same color here, directly across. Is that another x times h?
Yes.
Those two are done. Now, the piece out front. There's a piece out here staring at me out front, which I have not shaded. It's out here. Let's go through like they do it. Guys, what might be careful here, length times width, base times height, that's another rectangle staring at me out front. What might be the area of it? Another xh, is it? Is it another xh? For the one out front?
Yeah.
Okay, so here we go with that. I'm gonna add and use a different color here. Say this is xh. And is there also a face or a piece of the box in the back? Is there another remaining piece of the box in the back?
Yes.
What might the area of that be?
XH.
Is that going to be another xh as you glance at the back of the box? Length times width. Now I have 1, 2, 3, 4, 5 pieces to this area. Not 6, because he told me the top is what? Open. And I think, please tell me, again, just read to me, what are they asking me to find now?
Express the amount of material used to make such a box as a function of the length x of the side of the square base.
In other words, find A of X. Find the area. They call it surface area. There's 5 areas going on here. Find the surface area. And you say, Professor, like f of x, g of x, h of x, they want it only in terms of x. So I got to find this. A of x. My issue is, when I start combining all these for a total, guys, I think at this point, if I do it correctly here, I got what? X squared plus, what was it, 4 xh?
Yep.
When I combine like terms, is that true?
Mm-hmm.
So what's the problem?
We need to find the h.
Yeah, thank you. They're saying, no, don't stop there. They do not want that h in the answer. They want this final area to be A of x, only in terms of x. And then you'll have the formula or the function they need. Guys, does anyone have an idea of how to get rid of that h? And finally have everything in terms of only x. Go for it.
Maybe if we look at the volume formula, we can express that h equals 10 divided by x.
Love it. Look at this. If you go back and divide both sides by x squared, there's h. H is equal to 10 over x squared. And what was just given to me says, Professor, just take this and substitute right there. And now write this as x squared plus 4x. And now in place of h would be 10 over x squared. Close that up. Now guys, please tell me if that substitution now is everything at least in terms of x. They want everything in terms of x, A of x, I got it. Clean this up a little bit, this is x squared. From algebra, I see 4 times 10 is 40. I'll get that out of the way. I can cancel one of the x's out and have that when I simplify it. X squared plus 40 over x. Now what does that express? That expresses the area. You said, Professor, there's no such thing as an area of a box, is there? Volume makes sense. Area, that's why they call it surface area. Okay, so there's the surface area of that box with an open top. Now, and they did not ask me to do anything else with it, I don't think. They just asked me to write the function. I didn't have to put any numbers in at all. Now, Wednesday, when you walk in, if I say now it's a closed box, can you tell me the difference? What should your answer now be if you're also supposed to include, which I didn't, include this? Yes,
We just add the extra two, so,
do it again.
we just add an extra two, so 2x.
Not two, you're gonna add a what?
Well,
Another what?
x squared.
X squared.
Yeah.
So your answer now is gonna be 2x squared plus 40 over x. And that's the surface area. How can you go wrong? How can you go wrong? Okay, Mr. Park, Yasuji, the reason I brought this in is, and I understand why that math professor always has this on his first exam, he then will ask students to maximize this. Find the maximum area based on what's given, and that involves some calculus. At least when you see this, if you have that particular professor, at least you'll know how to draw the box and express the surface area, and then he or she will show you how to find the maximum area after that point. That's all we need to do though. So guys, on Wednesday's quiz, it's gonna be a box problem. It could be the one I did at first, where I cut the little corners out. Remember, I took the sheet of paper and I cut the little corners out, did up the sides and formed a box. That's, I think, problem number 1 on that handout. Or it could be something like this. Now, the more interesting one, though, of the word problems is, you guys are blessed. You guys are blessed. My students have better be at the top in those calc classes. You guys move on to Math 7 and you're at the top? Mr. Park, I'll find you, right? I found him in his professor's office the other day talking about that test or something, right? Yeah. Okay, guys. We're going to start and finish up. Had a good class tonight. Doing something with this. Thanks for reading that for us. You see those mistakes you made on that test? Those silly mistakes. There goes 2. Okay, guys, I'm sort of, that board's a mess. Sort of built up to this, is where I'm closing down. More than likely it's gonna take the rest of the period, rest of the time, close this down. with all that's been done. Here's what we'll do. Part one, you guys with me at 4 o'clock, we sort of glanced at this. So on your handout that you have right there, let's see, how are we going to close all this down? And can we get through all this? Guys, part one has A and B. I'm going to do only B. It says determine without graphing, no graphing, whether the function has, a quadratic function, has a maximum value or a minimum value. And since you guys have that on your handout, it looks like this. And no graphing like you had to on that exam. No graphing required. Now, the handout says, would you have a max or a min first, the way the function looks? Yeah, it's going to graph into a parabola. The parabola does what? Opens down. And since it opens down, definitely, you have a max. Now notice, I'm not asking you to complete the square like I did on the exam. No graph required, no completion of the square. I'd like to know where, what is the maximum value that this function will take on. Now from last week, we found, I think, a shortcut. Can anyone remember what I might want to do first in the attempt to find where or what is that maximum value? And please, Professor, don't ask me to go through completion of the square and find the vertex and graph and all that. Just find the max. What should I do?
Negative b over 2a.
X is equal to, by formula, negative b over 2a. In this case, that's negative, and then make my replacements, that's a negative 3 over 2 times a negative 2. All together, guys, I think you're going to end up with a negative with the sign there. I think it's 3 over 4. Is that true? Now, is that my answer? Is that the maximum value this particular function is going to take on?
No.
Or do I need more? Who recalls from last week?
What now?
Was there another formula?
Yes.
Some students may say, Professor, I saw what you were doing last week, and I think there was another formula that looked like this. 4ac subtract b squared all over what?
4a.
4a. Some students don't mind formulas. So if you use this formula, that'll tell you the y value. In other words, the maximum value that I'm looking for. Or if I don't want to use the formula, is there an alternative to find what that maximum value is? Go for it.
We can just plug the x value back.
Thank you. She said, Professor. Bella says, Professor, just take this negative 3/4, even though it is a fraction here, and take it back and plug it in. Replace it. Let me do it both ways. Just for my students who may want to use the formula. If I use the formula, this is 4 times a, looking back at my function, a is negative 2, c is positive 2, and it says subtract b squared, that's negative 3 squared, all over 4 times a, 4 times a negative 2. If you want to crunch it out by formula. Guys, all of this is a negative 16. Subtract, when you square this, that's a 9, over negative 8. When I crunch this out, this becomes a negative 25 over a negative 8, which comes out to be a positive, 25 over 8, and we all know that's 3 1/8. Is that true? Now, before I do it the other way, I'm saying, you're saying, if you remember what I did last week, let's say I do have my 35 students all today. I think I'm missing one. 35. And I asked my 34 students today, please replace x by a number of your choice. I don't care what you put in here. The domains, all real numbers. Replace x by any number of your choice. Crunch it out. Tell me what answer you get. And all of a sudden I check the papers and what students says, Professor, I'll replace x by, and they tell me what they replaced x by of their choice. They crunched it out, and they got an answer of 5. They put their X value in, they crunched it out, and they said, Professor, I got it. I said, what'd you get, 5? You're wrong. Why would I say quickly, without me taking the time to plug in their number to check it? It can't be 5. You can't get 5 to come out. I don't care what number you put in there for X. Why? The maximum value is how much? 3 1/8. That's what this means. That's the highest coming out that you can get, 3 1/8. You can't get a 5. Now, another student may say, Professor, I'll replace X by a number, and I'll say, what number did you put in there? And they'll tell me the number, crunch it out, and Professor, I got, let's say, -2. Could I at least accept it? Is it less than that max? So -2 is possible. But anything over 3 1/8, I can't use. It will not come out. That's what that max means. Now, that's the answer. You got the fit. That's all we're looking for. But I heard Bella told me, said, Professor, another way, and myself, I get this formula a little mixed up at times. You know why? Because we're so accustomed to b squared coming first. B squared minus 4ac in that quadratic formula, and some students will confuse it. But it works if you want to memorize it. The other way, Bella says, Professor, just take this -3/4 back and plug that in and crunch the number out. May take a little effort, but she says it works. And it looks like this. Replacing. And she's saying, Professor, if you crunch it out correctly, you'll get in 3 1/8. Let's see if we do. It's a -2. If I square this, 9/16. This is a positive. 9/4 plus 2. I could cancel 2 into 16 to make this look better than 8. So the first term is -9/8. Let's put everything in terms of 8, the common denominator. What is this? 18/8? And I think this is what, 16/8? That true, guys? Just trying to combine my numbers with the common denominator. The answer is going to be over 8. And I guess that answer is going to be whatever this is. At -9 plus 18, 9 plus 16, 25? Same answer? So you could just directly replace or substitute in there and get the same answer rather than that formula. It's up to you. Now, I want to do that. That's done on that handout. The next thing on the handout, I gave 2 graphs. Graph number 1, do this, guys, if you have the handout. Graph number 1 looks like, just a rough sketch, you have it there on your handout. Something that does this. And they labeled the vertex as -3, 5. They gave that to me. And it passes through a point down here on the y-axis, 0, -4. When you step back and look at it, it looks pretty good. It was nice of them to graph it for us. I didn't ask you to graph it, the graph's given to you. Now they're going to ask you to name the function this graph came from. You guys in the 4 o'clock session, we said if they want the function, this is a quadratic, Professor, it could look like this, which we've seen since day 1, or it could look like this. I'm going to write like this, guys. Most textbooks will write it. This is called the vertex form. In fact, this is the form that you had to do on that last exam. Remember doing this by completion of the square? And they call it a times x minus, they like to use h, x minus h squared plus k. It's called the vertex form. And there's another form there if you need it. Now, based on what they have given me, I need to write the function. Now, to save me a little time, you guys were with me at 4 o'clock, give me some input based on what you see here. how can I name the function that this graph came from? Anyone?
Can you use the vertex?
Now, thank goodness the vertex was given to me. So this says, at this point right here, f of x is equal to, I don't know what the a is yet, but guys, inside here, what would I have to write to get -3? Was it x plus 3?
Yes.
Horizontal shift. And of course, on the side there, for a vertical shift up 5, I need 5. Does that make sense? A horizontal shift to the left, -3, then up 5, that gets me the vertex. Thank goodness they gave the vertex to me, the turning point. Now the a is missing. And I know the way the graph looks, it should be a negative. The parabola is opening down. But what is it? Is it -2? Is it -1/2? Is it -2/3? It's negative something. Now how am I going to find it? Thank goodness they gave another point to me. I can label this as x and a y. And I go to what I have right now and replace y with a -4, f of x, and x with 0. And write this now at this point like this. Thank goodness they gave another point to me. If I calculate this, this is -4. Guys, I think it is 9a plus 5. If I solve this, I've got the end of the board here. This is -9 equals 9a. I'll put it on the side here. Is it -1? I did it quickly. Is it, guys? Is a -1 if you solve for a?
Yes.
It was? Therefore, my function right now, look at this. For this graph, a is a -1. We have x plus 3 squared plus 5. And there's the function that that graph represents. Make sense? Now, if you want to put it in this form here, what would you do with what I have? I have it in vertex form. What would you do to rewrite it if they wish and make it take this form? What could I do with my answer and make it look like this?
Multiply it.
Yeah, it's multiply it out. Just expand it out. You're finished. Now, was there another graph on there? There was. Oh boy, here we go. Since you have it there, this one looked something like this. And I had a student near the 4 o'clock session who helped us out. But I'm not to the good part of this handout yet. We're getting there. This one looks like this. It's a parabola. Oh, it's opening up. And they gave me this to work with. This is -3 up 5, given. Directly across, I guess this is 3, 5. If I'm reading that correctly. No, that's -1, wasn't it? There's the wrong number in there. -1, 5, 3, 5. And all of a sudden they threw this in. Y-intercept 0, -1. Now, I think I have my numbers in there correct. Now, they want you to write the equation, the function, that that graph came from. This one's different. It's not as easily done as this one. What's the difference in this one that I just finished up, which was not very hard compared to this one? They gave the vertex to you. They gave the vertex to you. Just make it easy. This one, the vertex is not given. Yeah, my student in the 4 o'clock session suggested this. It's telling me, Professor, could I now use, not the vertex form, but could I use this form on this particular one? I don't know what the vertex is, so maybe stay away from this right here for a while, and use the other form, ax squared plus bx plus c. And then I asked, do what with it? Vertex is missing. And we use the other form. What can I do with it? Based on what you see.
The numbers.
Now watch what happens here. They gave me 3 points. Darn it. Of those 3 points that they gave me, they didn't give me that. If they give me the vertex to me, I'd be finished in no time. I'd do it like this one. They did not give the vertex to me, so this one requires a little bit more work. Bella.
We know what C is because we had the Y and stuff.
Okay, she says, Professor, if I start with this point right here, this is the X, this is the Y. She says, if I go to the function that you have written there, in that form, and I find f of 0, in other words, replace the, hang on, make it even easier. She said, Professor, y is -1 when x is 0. She's telling me, Professor, it just comes down to that. That right there means this. You guys agree? Replace the x's by 0, and the other side, the y should be -1. That's what that point represents. Thank goodness. Bella, thank you. That drops out. She says you have immediately found C. Therefore, I could, and I'll put right here, slow down and say, now the function looks like this. F of x is equal to ax squared plus bx minus 1. C is -1. Now that's looking good. What else do I need to find? I need to find the a and the b. Now, can anyone give me a suggestion from there? Because I'm not quite finished. I need the a value, the b value, and Bella got the c value for us. What can I do from there? I have more to work with. Thank goodness they gave it to me. I have 2 more points. So what am I going to do? I'm going to go to what I did here, and maybe now try this point. It's on the parabola, so this is another x, another y. Pick up with where you left off and replace y by 5, f of x, and the x is by -1. And you have this to look at this point. That's this. Using that new point over there. Clean this up the best I can. This is 5. I think this is 1a minus b minus 1. Step back and look at it. Guys, move that 1 over to make it look better. I think it says 6 is equal to a subtract b. Not a direct answer, but 6 is equal to a subtract b. Now what could I do for help? I'm desperate for this. What else can I do? Do I have another point that I could use? Some students may say, Professor, why didn't you use 3, 5? I'm going to use it now, rather than this other point you used. So we'll go back to here and try the other point, 3, 5. Okay, so guys, we've got 5 is equal to, if I use 3, 5, that's the xy, a 3 squared plus b times 3. And of course, we found that c way back. That's -1. That's this right here. 5 is equal to, do not let me make a mistake, this is 9a plus 3b minus 1. Better written as 6 is equal to 9a plus 3b. Oh my goodness. By the way, did I use everything that was given to me on that graph? They did not give me another point, did they? I think I had enough points to work with. Okay, guys, I'm looking for the A and B. Does anyone, can you reflect back to middle school? And what I should do, I should make arrangements with that middle school across the street. I know a couple of teachers over there, and have us come over and visit. Would it be nice to visit middle school again? Yeah, see what those middle school kids are doing over there. I think what we need to do on this one, they've done. I think they're doing this over there. Tell me, what from middle school can I do with these in an attempt to find the A and the B? Bella.
If they both equal 6, you can
Could be, you say both these are equal to what, 6? So she said, Professor, and then these two must be equal to one another. Could I do it like that, guys? I could. I want to make a connection to the middle school. I could do what you said. Yes?
Maybe we can present 6 equal to 9a plus 3b in the form that
But this,
a minus b, so we then change it to 6.
could I reduce it, in other words, could I reduce this one down first? If I wish. You wouldn't have to. Could I divide all this by 3? Maybe make it a little bit easier on me. Makes that 2, what, 3a plus what? b. Let's just reduce down. Now what am I going to do to get that middle school concept back into play here? We got 6 is equal to a subtract b, this one. Underneath it, we'll write this one. Now this should bring back fond memories of middle school. What on earth did all of us, I mean all of us, do in a case like this? They're lined up. I lined this one up with this one. I stacked them up. For what reason? Can I just combine them? Add them up? If I add them up, something nice is going to happen in this case. What's going to happen? Those cancel. So I'm going to end up with what? 8 is equal to 4a. Therefore, a has a value of what? 2. Now I know what a is. I know what c is. Only one left is b. Does anyone have an idea how to find b?
Plug in A.
Okay, now if you say plug it in, like where?
A equals 2, so put it in the top one, 6 equals 2 minus 6.
Oh, you want this right here? You plug it in here, you want to plug it in? You could.
Yeah.
We'll go directly across and you're saying 6 is equal to, A, professor is 2, subtract B.
Yeah.
Just make a substitution. And I think when you figure this out, guys, B is equal to, is that -4? That's -4.
Good.
Now, do I have all of them now? Do I have the A, the B, and the C? And therefore, what function represents this? I can write this form. Y is equal to, A was, remind me guys, with all this work here, where was A?
2.
A was 2. Yeah, 2x squared. B came out to be, what was it? -4. And of course, C was -1. There's the function that graph represents. That make sense? Now, can someone real quickly tell me, before I leave this and get to the good part of this handout? Oh, beautiful. These classes are way too short. Could I now easily, if I wish, could I easily find precisely where that vertex is?
Yes.
Yeah, I use a shortcut. X is equal to negative b over 2a, always works for a quadratic. So it's negative and -4 over twice 2. Watch my sign, please. Is that 1? I did it quickly. Is it 1 for the x? And you're going to use the formula for AC minus b squared. You could. I'm going to just go ahead and replace it. Substitute, find f of 1. Okay, guys, if I go to my function, replace those x's with a 1, it looks like this. 2, subtract 4, -2 minus 1, is that -3? Yes or no?
Yes.
Therefore, that tells me my vertex, turning point, has these coordinates. So out 1, down 3, should be that vertex, if I had to find it. How's that look? Any concerns about that? Okay. Now, if you're not enjoying this, and I don't know you that well yet, but if you're sitting there saying, I don't enjoy this, we need to get some help for you. There should be a smile on your face. There should be a smile on your face when you're doing this math too. You're saying, geez, professor, now I see what's going on here. It's making all kinds of sense. We should be enjoying this. Guys, these two are done. Now, the last of the handout. I've been waiting for this. I said on the quiz, we're going to have 2 word problems. One's going to be, I don't know whether I erased it over there or not, the box problem. We're going to have one like it. The other, here we go. From the handout, I want you to turn to the back first. We're going to do the one on the back first. In fact, there's 2 on the back. I want a student to read for me on the back there where it says section 2.6. Read that problem to us, and then we're going to set this up, and this is the most beautiful application of what we're doing in class. Who would like to read? Jeez. Yes.
A stone is thrown upward from the top of a building. Its height 10 feet above the ground after 2 seconds is given by h equals -16t squared plus 48t plus 32.
Nick T, hold on just a second. We got that, right? So stop right there. Now, they're telling me, and this could happen in calculus, and Susan, Mr. Park, it may have happened in your calc course. She's saying, Professor, we're on top of a building, and we're going to toss a ball into the air. A stone. We're going to throw a stone into the air. And I'm going to say, well, why are you on top of a building to begin with? And why are you going to throw a stone? Because I just received my test score, Professor. I'm a little upset. I got on top of the building and I had a stone. Oh, no, you don't do things like that. And that stone's going to be traveling. Now, we're hoping, neglecting the wind, friction, gravity, we're hoping it follows a parabola. They call it a parabolic shape, neglecting all those other factors. That's what she read to me. Someone on the top of a building will throw a stone into the air, and she says, Professor, they gave you the function for that parabola. I don't have to find it, they gave it to you. What was it, h of t? Okay, h of t, h for height. And it started with a -16t squared. And what else did they name for that h? Besides -16t squared, what else was there? 48t plus 32. I've been waiting all night to get to this problem. Oh, by the way, is that a quadratic? It's not in terms of x, it's in terms of t for this particular application. It's a quadratic. And by the way, I see a -16, that means the parabola should be doing what? Opening down? And it is opening down, based on what she gave me. Now, before I jump in and try to answer some questions here. Yes, it's negative. The parabola's opening down. Guys, this is in terms of t, not h of x, it's h of t. Why? Because we were talking about the height, that's the h. And the t is going to be time. So this function is written in terms of height and time. Now, she read that much to me. That's what's going on at this point. Yes?
Are you allowed to divide all by 16?
Do it again.
Are you allowed to divide everything by 16?
Hang on. No, then you have to complete the square. Now, after that it says, what is the maximum height reached by the stone? Classic problem to close down with. They're asking me to find this. What is the maximum height that stone will reach, stops in midair, and falls back down? What, in essence, are they asked me to find? The vertex. Please find that vertex, Professor. Now, I'm going to use the shortcut. I just had a student say, Professor, could I divide everything by negative 16? If you divide everything by negative 16 like you did on that last exam, exam 2, that coefficient will turn to a 1, which you want. You just have to complete the square. I'm going to leave mine just the way it was given to me. I'm not going to use completion of the square on it, like you did on the exam. I'm going to find it right quickly, guys. Keep in mind, this is t now. So t on the side here, not x, is equal to formula negative b over 2a. A t rather than x. Use my formula, that's a negative, and it looks like b back here is 48. And 2 times a, 2 times a negative 16 for the a. It's going to be a positive answer. It's 48 over 32, which I think could be reduced down by 16, I think. Is that 3 halves? So what I have right now is, Professor, you just found for an ordered pair, the first coordinate is 3 halves. By the way, can anyone tell me what that 3 halves means on this particular application?
At 1.5 seconds, it reaches the
That's
height.
time. That's t. So that means after I release and throw the stone, it's going to take 1 1/2 seconds for it to reach that maximum height. Then it stops and falls back down. Now, do I know the maximum height at this point? No, I know how much time. So what should I do to find the maximum height? Use the 4ac minus b squared business, or go back to my function and plug in, substitute, as we've done before, and find h of 3 halves. So guys, I'm going to use this method. Go back, make a substitution. Hope I do not make a mistake. And we have this. Let me step back and look at it. Looks good. So this is a negative 16. This is 9 over 4. I'll come back to it. Cancel here. 2 into 48 is 24. Just clean it up. This is 72. Here, plus 32. Go back. I can cancel a little bit here to make this look better. This is a negative 4. So this is a negative 36. Guys, all I'm doing right now is arithmetic. 72 plus 32. Now we step back. Oh my goodness. Is that 68? Add those numbers up. Is that 68? And what does that 68 represent?
60 other.
That's the highest that that stone will go. And I think she mentioned this is in feet. So this is 68 feet. That's the maximum height is 68 feet. How long does it take to get there? 1 1/2 seconds. Now could you guys do one like this? I said there's 2 word problems, a box problem and, one something like this. Could you do one like this? Of course you could. Some students are coming to me with a little physics. Well, they might be taking physics, yeah, but they already had a physics course. Does anyone, please tell me, before I go to the next part of this problem here, does anyone recognize what these numbers represent? They give it to you. Has anyone had a physics course where they could say, Professor, I sort of understand why they put a negative 16 there. They gave it to me, so I didn't argue with you. They gave a 48, and they gave a 32. Where'd those numbers come from? They gave it to me, you don't have to worry about it, just for curiosity.
32 the height.
No, 32 is the height. 32 is the height of the building.
Would the first term be gravity?
Yeah, there you go. This has something to do with
Second term
gravity,
is the speed of
acceleration, and this,
Speed,
speed of the stone.
velocity, the speed. So they've already calculated that for me. I need not worry about where those numbers came from. Physics gave it to me.
They're
That's
throwing
some-
it on Jupiter.
Yeah, well, very. But there's gravity involved, there's that velocity involved, and there's a height involved. They gave it to me, so I need not worry about it. Now though, I don't think I'm finished with the problem, am I? No. Since you're close by there, read the last of that problem.
How many seconds will it take for the stone to reach the ground?
Now, they're saying now the stone eventually is going to hit the ground. Of course it is. They're asking how many seconds after release will this hit the ground? Please tell me, what does that have to do with what we've been doing? Make a connection for me. How are you going to find the amount of time it takes for it not to go up to the maximum height, but to come back down and hit the ground? How much time is that? Can anyone tell me, what can I do to find it?
X intercept.
When it hits the ground, the height is 0. Is it?
Yeah.
When it hits the ground, h is 0. That means this side is 0. The height, there is no height. So I'm going to set 0 equal to this. And I need to solve that. Now we're back into day 1 when I first met you. We're back in day 1. You got to solve that quadratic. I'm going to first reduce this one down. I think I can reduce it down by 16 or a negative 16. Let's divide everything by negative 16. Make it look better. 0 is equal to t squared minus 3t minus 2. Guys, I just went through and divided everything by negative 16. And I hope I was careful enough with my signs. Oh, yeah, it looks good. That's a quadratic. We're back in day 1 when I first met you. Now I gotta solve that quadratic. I will tell you ahead of time to save me a little time. It will not factor. You can try to factor, it's not gonna factor. What other methods do we have? Quadratic formula, completion of the square, all that business. I'm gonna use quadratic formula. Now, this is t, not x. Quadratic formula, negative b, negative 3, plus minus square root b squared, negative 3 squared, subtract 4 times a, which is 1, c, which is negative 2, all over 2 times a, 2 times 1. If I'm careful, I see a 3 plus minus square root. Guys, underneath that square root, that's the common mistake. Be careful. I see, if you agree, I see 9 plus 8. Is that what's underneath there? Is that 9 plus 8? 17, not a nice number. Too bad it wasn't 16. 17 all over 2. Separate them. So one time I will consider as 3 plus radical 17 over 2. The other separated is 3 minus square root 17 over 2. Let's separate them.
We only be concerned with the first one because.
Now why must
usually
I?
not pass.
Why must I reject one of those? Based on what we were asked to find. We were asked to find time. Is one of these answers negative? I know square root 17 is 4 point something. So this down here would be 3 subtract 4 point something. This would give me a negative result. I don't want that, not for time. So this is out. I'll accept this. I think this is in seconds. I will not ask you to approximate. 3 plus radical 17 all over 2 is the amount of time it's going to take for it to hit the ground. Mr. Park, I'm so glad I got my TAs in here. Susan, did the Math 7 ask you on a problem like this? Did the Math 7 also ask you at what velocity does it hit the ground?
I think also we calculate like the work.
For work, yeah. No, let's just stick to the height problem here. Let's not do work. It's not a work type problem. Yusujin, so you're saying you do remember now they also ask you for like at what velocity does it hit the ground? Yeah, that's another part of calculus. So besides the time it takes, they're going to ask you to count now what velocity does it strike the ground? And they'll help you out there, and that's 7. Guys, any concerns here so far on this? What a beautiful job your instructor's done. What a beautiful job your 2 TAs have done. What a beautiful job SMC's done. You're very blessed to be here. You'll find out after you leave us, oh, I was blessed to have been at SMC after you leave us. You'll realize all that. Now, I see I got 5 minutes. Do I have 5 minutes?
Yes.
5 minutes. Was there on that handout, hang on, I'm just sure do this, your quiz on Wednesday. So nobody's gonna email me and say, Professor, what's the quiz? What's the quiz gonna be on? 2 word problems. One's gonna be a box problem. And the other one's gonna be a stone being tossed into the air, something being tossed into the air, and ask you for the height, the time it takes to get there, the time it takes to hit the ground, those types of problems. Just 2 problems. Now, the last one on that handout. I had a sketch for you. Did I sort of did I say something about calculus at the top there? What did I say there? I think I phrased it some way there before we start the problem. What was it? Extension into calculus. You're talking about an extension. Into calculus. Did I give you a sketch?
Yes.
Would you please read what am I asked to find on that problem? Whenever I actually finished up, guys, we set it up. Yeah.
Find the maximum vertical distance between the parabola and the line for the given region.
Did I sort of drop, can you see the vertical line I dropped between the 2 curves?
Yes.
They're saying, what is the maximum distance as you travel along those 2 curves, and you know those 2 curves are intersecting. They want to know what is the maximum height those 2 curves are apart. Any ideas before we leave? What is the maximum height? Take it, I think I took this from a calc book. Someone please make a connection, make my night better for me as I drive on the freeway. Go for it.
Maybe because it's triangle.
No, I'll stop you because I got a limited time. Yeah, no, something else can be involved. I don't want to cut you too short. No, something easier than that. Did I label the top point for you? Or would you know by the way it's worded what the top point is? Was the top point on the line? Was it? Yeah. Okay, could I label a point up there at the top on the line as x? Did I give the equation for the line?
Yes.
As?
Negative x plus 3.
Negative x plus 3. Look at this. Oh, you're going to love this. Should have saved this for an extra credit. Oh, you know what? Whoa. This is going to be an extra credit Wednesday. I will set that for you. I'm not going to give you the answer. Was the bottom point on the parabola? Was it directly beneath?
Yes.
Okay, so x, and what was its name?
2x squared plus 8x plus 4.
2x squared plus 8x plus 4. Now they're asking you to find the maximum. There's maximum. Negative b over 2a. The maximum distance between those 2 points. Think about it. Good luck. I'll probably give you a couple points. We can get that to work out for an extra credit. So try it. Talk about it. And we'll give you that as an extra credit. Okay, guys, we're done. If you did not receive your test exam back, make sure you check with me.